If you're just here for the results, the answer appears to be that heat plays a role and the ultrasonic action is needed to help with the cleaning or de-scumming action as the surface is affected. The rest of this video provides other commentary on what I did. I have wondered about using Evaporust in the ultrasonic cleaner to speed things up between the ultrasonic action and the heating that's available in a lot of them. I've seen that people do this, but nobody has really teased apart the different variables of heat and ultrasonic versus Evaporust, versus plain water. So let's test some of these, and then hopefully we can get some good qualitative and quantitative results that tease apart all the different factors involved in this. There's content online which demonstrates that using Evaporust in ultrasonic cleaners results in a faster and better end result. I don't dispute that, but wondered a few things. Was heating or preheating used? What times and temperatures were involved? What about different materials and types of rust conditions? How much does just ultrasonic action matter as if the part was in water? How does time in ultrasonic compare to non-ultrasonic longer durations? Were the parts scrubbed clean in those videos, or was what we saw just the part straight out of the ultrasonic cleaner? I planned a matrix of tests to let us compare each of these factors against each other. I selected two different materials that I had a few feet of in the scrap pile outside. One is some 100-year-old structural iron of some kind. The other is more modern steel, mild steel structural section with a few years of different colors of surface rust, but no major pitting or deterioration. So now I'll summarize the test conditions. First at the bottom, I have these what I call dry controls. These are pieces of the original material with no treatment or cleaning. By the way, all the cuts were done dry. No coolant or oil was used because I didn't want to contaminate the surfaces and introduce inconsistencies. I did 3 parts for each test, just in case we had different paint or oil contamination or anything that was on or in the rust. And I mixed them all up before I pulled at random, so it's not like these 3 pieces were all cut right next to each other. In this grid of pieces at the top, there are 4 rows, each representing a combination of liquid and material. For example, the top row is all steel pieces in water. The columns are the combinations of temperature and whether or not the ultrasonic cleaner was used. The first column is 12 hours, which I call the wet controls. They're meant to be representative of how parts are more conventionally used in Evaporust. The other 4 columns are 1 hour duration and cover the 4 cases of temperature being ambient versus heated, and whether or not the ultrasonic was on versus the parts just being in the heated bath. Each column was done at the same time together, so each of these parts were in 4 separate jars of Evaporust in the ultrasonic cleaner. All tests were done with brand new Evaporust, so this jar had its own fresh Evaporust, as did this separately. I did not test different durations of time in the ultrasonic cleaner, because that would add a whole nother set of tests, and it would have gotten out of hand. At least for now, I did 1 hour for all the ultrasonic and heated tests, so that the sensitivity of those factors can be understood. Then in the future, perhaps a narrower set of test cases can be done, with more durations introduced as a variable. I don't want this video to be long, so I'm only going to point out a few key conclusions. If there's interest, I'll do a longer video that goes through all of the considerations, observations, how I did this test and why, what I kept consistent versus not, what I thought was significant and not, and then I can go through pictures or notes on all of the different individual pieces. I did do a brief test at first to show that having parts in jars, and 4 jars in the ultrasonic cleaner at once did not impact the ultrasonic action. I'm not going to go into detail, but basically I put pieces of aluminum foil in the bath itself versus in the jars and made sure that they deteriorated the same. Unheated and ambient are a bit of a misnomer. The fact is that the ambient pieces still got heated up because the ultrasonic cleaner generates heat, waste heat by being used. That does increase the temperature. I have temperature measurements and graphs that would be in a longer video about that. So really the ambient stuff here ended up being more or less whether it was preheated, whereas the hot tests were brought up to temperature first, and then the parts were added and the machine was turned on. So what we were really testing is how does preheating affect performance, because the hot parts were at 115 degrees Fahrenheit or higher the whole time. The iron did not see a huge improvement during these tests. The depth and type of corrosion was different than the steel and probably needed a lot longer treatment. However, in the pieces that had the hot ultrasonic, the preheated ultrasonic test, you can see spots of gray matte iron coming through, whereas on the non-preheated Evaporust test, you really don't see that nearly as much. All of the samples in the top half that were in water had no meaningful change. This is not surprising. Water doesn't do anything. But I just needed to know that having them in ultrasonic or soaking wasn't going to cause things to flake off or get cleaned off that would otherwise have some of the behaviors get misattributed to the other factors. For example, running things in hot ultrasonic water maybe would have caused some of the heavier corrosion to flake off the iron. I wouldn't have known that unless I tested it. It did not seem to be a significant contributor in any way. All of these parts were only blown dry, not rubbed, scrubbed, or toweled off. That, I think, plays a pretty significant role. And again, I couldn't test that variable here because the set would have gotten too big. But we can see that, the 12-hour parts did have significant improvements, but anybody who's used Evaporust knows that they end up with a green, gray, or black slime on the surface a lot of parts. And if you don't rub that and scrub that as you rinse the parts off, you end up with this kind of finish. So, and we can see that highlighted in the difference here. We have these parts were 1 hour hot with no ultrasonic, and this was done with ultrasonic. So the cleaning action is significant, but without wiping it off, we don't know whether this part would have looked more like this. So that's just something worth calling out, that in these tests I did not scrub anything because I did not want to introduce that as a variable. So the overarching conclusion is that both heat and ultrasonic action contribute to the improved performance. I believe that this is because, like other things in basic chemistry, the heat speeds up the actual reaction, and the ultrasonic cleaning action and agitation continually removes the accumulated residues and exposes the surface to fresh solution. These probably work together to convect and agitate the solution, whereas parts that just sat in the jar for 1 or 12 hours clearly showed that the solution was unmixed based on the color gradient that showed up over time, whereas the ultrasonic jars had a more homogeneous appearance to the liquid. All right, so what about final thoughts and future work? It's interesting to see the difference in performance between iron and steel for the different corrosion and types of rust they presented. The biggest question left here is how much the heat versus ultrasonic actually contribute. There are two things that kept us from truly separating those factors here. One is that the ultrasonic cleaner inherently heats up during use. The other is that I did not scrub or wipe the parts off after each run. If I do more tests, I would take some actions to keep it cooled off for the unheated tests. Maybe running a fan across it so there's evaporative cooling during the run. Or maybe running the liquid through some kind of heat exchanger with a fan to actively cool it and keep it closer to room temperature. Also, changing the duration means that if it starts from cold and I only run it for 15 or 30 minutes instead of an hour, more of the time is going to be spent cold versus with a preheat, that becomes more substantial for shorter run times. And then also maybe wiping off or scrubbing the non-ultrasonic parts like we just saw. Maybe scrubbing those off would make a bigger difference to the end result than we see here. That's it for this short video. If there's interest in more detail or some of those other tests, maybe I'll get up to those and do a follow-up video with more tests and some of the more detailed observations and notes and video and pictures I took along the way. Otherwise, thanks for watching, and you'll see me in whatever I get up to next.